I mentioned earlier that lifting an 800-pound concrete slab is gonna place a stress more than 800 pounds on the slings if they are not in the direction of the pull, if they are not aligned vertically. And in this video I'll show you what I mean by this. I have here these two force gauges from the physics lab, nothing digital, nothing fancy, just some beat up student force gauges. I have here a test load with hooks in them that we can check what stress it places on the force gauge in vertical configuration. That would be the single vertical hitch. If I hook the two force gauges up in this one, this would be position 1, position 2, position 3 would be here, and the last pair of hooks would be position 4. And you can see it with your own eyes and take a look at the readings on the force gauges. It's not rocket science, but it's quite surprising. So for a starter, let's see single vertical hitch, and I'll just compare these two force gauges briefly. So that one reads 470. If I zoom in a little bit, you can actually see it. 460. We'll go for 465. How about that? Let me see. Sorry. Yeah, 465 on this one, and the other, just to compare them. And the other one is there, 465. We'll go with that, okay? So that's single vertical hitch, and I have two force gauges side by side, and let's see what happens when I hook them up this way. Just gotta make sure that the hooks are nice and even enough up here, and they are nice and even down there. You see it's not touching the table or anything, but I'm gonna record some of these observations here, because for vertical pull we had 465 grams. Okay, let's see what we have here when the two slings are not in a vertical lift. What I mean by that again is that the two slings are not in the direction of the pull, not vertical. In this situation, that one reads 250, that one reads 240. I guess we can average it out to be 245 each. How about that? Give me a little slack and let's work with that, because these need to be meticulously the same to show the same amount of stress. Let's go for 245. However, so that's 245 each. Let's double it because we have two of them. Let's do it on a calculator where you can see 245 times 2 equals 490. So what happened here right away is the 465 gram load is now placing a combined 490 gram stress on these slings, because they are not in a vertical hitch configuration. Now the difference between 465 and 490 is not much, so let's double check and verify it. Let's hook them up into position 2, see what we get out of this one. It's not touching the table, it's just rotating a little bit, because that's the only way this is gonna work, or this is gonna hold it. So that one says 260. Let's zoom in where you can see it. There, you can see that one says 260 and that one says 260. There. So if I write 260 on the paper here and double it, let's do 260 times 2 equals 520. 520, and it's obvious from this one that the piece of wood, 520, sorry, that the piece of wood is not getting heavier. It's the same piece of wood that's being lifted. The only thing that changes, and the force gauges are not changing either, they have the same spring inside. The only thing that's changing is the angle of the force gauges. The pattern here continues. If I rig it in this configuration there, because they want to rotate a little bit this way on their own. I don't know if you can see that one, 310, and that one 315-ish. Okay, let's just go a little closer so you can see some numbers there. 315, the other one is 310. So let me just write down 300 and how about 312, okay? And let's double that. That's gonna be, there's 312, 2 by 2 is 4, 2 by 1 is 2, 2 by 3 is 6. Now it's 624 grams of stress, because it's not a vertical lift. Again, the weight of the wood didn't change. The only thing that changed, see, it's still a 465 gram piece of wood, but now the stress is over 600 grams. So that's about time and a half or so. Time and a half as much stress on the slings as initially in vertical pull. Lastly, let's do it this way. Okay, a sec. Let me just hold it so they don't really fall over. Okay, it's gonna rotate. It's gonna want to rotate that way, so I'll take you off the tripod. And then you can see it with your own eyes. And that one says, just wait for the camera to focus. There we go. 410, 420, 430. There, that's 430 if you look at it this way, dead on, 430. And the other one is also there, that would be no parallax. 410, 420, 430. Okay, both of them say 430, and the load is rigged up in this extreme angle here. That would be 430. Let's double that quickly. That's 860 grams. Well, it's not quite, but it's getting there. It's almost twice the stress than in a vertical hitch configuration. So, what's the lesson here? The lesson for rigging is try to arrange your slings as close to vertical as possible. Even if it's a basket hitch, try to arrange them as close to vertical, the legs on the basket hitch, as possible. And on a choker, if you have a pipe to lift and you have a sling that you set on a choker, don't tighten it down to the pipe. Leave it running towards the hook, towards the point of lift, so that the choker kind of cradles a round pipe or so, whatever you're lifting, with the legs of the sling as close to vertical as possible, because that's the least amount of stress on the slings. This stuff can be calculated predictably. Do take a look that the distance from here, the vertical distance, is getting less and less and less. This is called headroom in your calculation. It's going to be abbreviated with H, and this is going to be L, length of sling. Okay, take a look at this. We have here, I'm just going to turn it out. We have here a right angle triangle with headroom, and the force gauge here is being the hypotenuse. On the job site, your chain slings or wire rope, whatever slings you use, that's going to be the hypotenuse. of this right angle triangle, and I don't mean this whole thing, just one triangle at a time with just one sling. Okay, headroom and length of sling.